Hello and welcome to my channel Simonrebello #scholastic tutorials. Today we are going to study theorem. Angles inscribed in the same arc are congruent. Here we have a circle with center O. Here I have drawn an inscribed angle. I name it as A, B, C. Angles inscribed in the same arc. Now this arc is known as intercepted arc. An angle ABC is inscribed in the arc ABC. I name this arc as AXC. The angle ABC is inscribed in the arc ABC. Suppose angle ABC was 70 degrees. The measure of the arc AXC will be 140. That is called inscribed angle. Angle ABC is half of arc AXC. Now they have said angles inscribed in the same arc are congruent. I draw another angle and name this as D. Angle ADC now will be how much? If this is 140, obviously this angle will be 70 degrees. So we see angles inscribed in the same arc, that is ABC. In the arc ABC you name it, or ADC. These two angles are congruent. Another theorem. Prove that the opposite angles of a cyclic quadrilateral are supplementary. Prove that the opposite angles of a cyclic quadrilateral are supplementary. Supplementary means 180 degrees. Now here I have a circle and the 4 points of the quadrilateral lie on the circle with center O. I name this quadrilateral A, B, C and D. I have to show angle A plus angle C is 180 and angle B plus angle D is 180 degrees. Now very first we should know the measure of the arc of a circle is 360 degrees. And I have known inscribed angle theorem stating that angle BAD, that is angle A, is half of arc BCD. And angle C is half of arc BAD. Arc BAD and arc BCD together will make 360 degrees. Now I know angle A is half of arc BCD. This angle is half of arc BCD. Angle C is half of arc BAD. Angle C is half of arc BAD. Now if I add A plus C, angle A plus angle C is equals to, if I add the left hand side, my right hand side also have to add. So I'll get a half BCD plus half arc BAD, half will be common, so I'll get BCD plus BAD, that is arc BCD and arc BAD. Arc BCD and arc BAD together will make 360, that is half of 360, sum of angles, arcs of a circle. I cut and I'll get now here 2 1s are 2 180s are, so that will be 180 degrees. So angle A plus C will be 180 degrees. Similarly, I can say B plus D is 180. So what I had to prove was that the opposite angles of a cyclic quadrilateral are supplementary, that is A plus C and B plus D. I get A plus C is 180 degrees. Similarly, I can show B plus D is 180 degrees. Next theorem, tangents drawn from an external point are congruent. Here we have a circle with center O, tangent AP and PB, tangent PB, the tangent at point A and point B. I have to show that AP is congruent to BP. Tangents are congruent. Very first, I will join the radius to the tangent, and I should know radius is always perpendicular to tangent at the point of contact. So this will be 90 degrees. Here also 90. I will join OP as well. I go to triangle 1, that is AOP, and triangle BOP. These two triangles I'll select. Now radiuses are congruent, they are called radii. OP is common side, and angle A and angle B are congruent, each is 90 degrees. So when I go to triangle AOP and triangle BOP, AO is congruent to BO, radii. Next, I can say OP is congruent to OP, common side. Angle A congruent to angle B, each is 90 degrees. Each angle is 90. Each angle is 90 degrees. Therefore, I can say triangle AOP is congruent to triangle BOP by hypotenuse side test. So by hypotenuse side test, here also I have got a hypotenuse and a side, the two triangles are congruent. Therefore, I will get AP congruent to BP. That is called the corresponding sides of congruent triangles. Next theorem, angle inscribed in a semicircle is a right angle. Here I have a circle with center O. Here I draw the diameter AB, and this point is C. This arc is AXB. Angle inscribed in a semicircle, when this is a diameter, this is a semicircle. So angle inscribed in a semicircle, I have to show this is right angle. Now if this is a diameter, this semicircle, this semi-arc will be 180, and by inscribed angle theorem, if this arc is 180, then this arc will be 90 degrees. So first I will say AB is diameter, then I will say angle ACB is equal to half of arc AXB, inscribed angle theorem, that is half into 180, that will give me 90 degrees. Hence I will get angle inscribed in a semicircle is a right angle.